Hello everyone and welcome back. My name is Mr. Kovalt, and in this video we're going to go over a problem where you are asked to find the identity of a metal in a metal chloride, and you're given the change in vapor pressure compared to the that of water. So let's get into this. By the way, this is a problem or a question brought to you by Emmanuel Almendarez 242. So thank you, Emmanuel, for this question. This is for you. So, what's the question? We have a 10.0 gram sample of the metal chloride salt, and it's dissolved in 90.0 grams of water. This solution has a vapor pressure that is 8.6% lower than that of pure water at the same temperature. What is the identity of the metal? So first, right off the bat, this is a Raoult's law kind of problem. So we're going to need to use Raoult's law or the vapor pressure equations. And also keep in mind that whenever they're asking you to find the identity of a metal, the way we're going to do that is finding the molar mass. Because once you find the molar mass, you can look on the periodic table and then compare and find what element or metal is closest to that molar mass. So that's what we're going to need to do. So first thing we need to do is write the equation. Now, there's several different ways you can approach this, but they're all pretty similar. But it's the beginning of it might change a little bit, but the way I'm going to do it, I'm going to use this equation. So we know that the partial pressure or the vapor pressure of the solution, okay, is going to be equal to the mole fraction, which is represented by the Greek letter chi, multiplied by the partial pressure of the solvent, right? So in this case, the solvent is water. So we can put water here, H2O. And so let me double check here. Okay, and this chi-squared, we need to identify this as either the solute or the solvent. But here, the chi, the mole fraction, is that of the solvent. So let me write that out to make that clear. Multiplied by the partial pressure of water, or the vapor pressure of water, pure water, under the same conditions. So solvent, and again, the solvent is water, H2O. So this is the equation we're going to use to start with. So what do we do with this 8.6%? Again, there's a few ways you could do this, but one way is I know that what they're telling me is that the vapor pressure of the solution is 8.6% lower than what you would expect for the pure water. So if the water was 100, then the metal would be 8.6 lower. So because remember, 8% or a percentage is out of 100, so 8.6% is 8.6 out of 100. So I could write this way. The partial pressure of the solution is going to be equal to 91.4 out of 100, right? So out of 100 is the percentage. If the partial pressure of the solution is 8.6 lower than that of water, and we say, okay, well, let's make water 100, then it's going to be 8.6 less than that. That gives us 91.4 out of 100. Okay, and then we multiply that by the partial pressure of the water. So whatever the water is, we're going to multiply that by this percentage. that's going to give us the partial pressure of the solution. So whatever the partial pressure of water is, that could be anything. We know that whatever this is, the partial pressure of the solution is going to be 91.4% of that, right? So now that I have this, I can substitute this in for this. So then this becomes 91.4 out of 100 multiplied by P, the partial pressure of water, or the vapor pressure of water, pure water, is equal to the mole fraction of water multiplied by the vapor pressure of water. So look here. So if I divide both sides by the vapor pressure of pure water, so this cancels out, and then this cancels out. So if I divide this, I get 0.914. So this is going to be 0.194, 914, not 194. Dyslexia. Okay, so 0.914 is now equal to the mole fraction of water. Okay, so now we have this. So now we have to break the mole fraction of water down. So let's go ahead and erase this. We're going to come back up here. So 0.914 is equal to the mole fraction of water. And what is the mole fraction of water equal to? That is equal to the moles of water over the total moles of what you mix together in the solution. So we're going to have N. N represents the number of moles. So here is going to be N of H2O over, and then what's the solution, right? The total number of moles is the moles of water plus the moles of the metal chloride that you put in the water, right? So it's going to be N of water, the moles of water, plus the moles of the metal chloride, MCl. Okay, so then this is the relationship that we have now. Okay, so now, one of the things you got to keep in mind is that this is not merely moles of the ionic substance, right? So you have to remember that the key here is in this solution, the ionic salt has dissolved. So the moles here is not the moles of the metal chloride, it's the moles of ions in solution. So remember, and this is key, I think a lot of people forget about this and then they don't get the right answer, is that the moles, the vapor pressure lowering is not due to moles of the metal chloride, it's due to the number of particles or the moles of all of the ions in the solution, right? So here, maybe this would be better as ions. The moles of all the ions in the solution plus the moles of water. Okay, so, and we'll come back to this in a moment, but I just want to make sure that you understand that, because I think a lot of people forget that this moles is not the moles of the formula of the metal chloride, but is the moles of all the ions that are now dissolved in the water from the metal chloride. All right, so now the moles of water, we know that 90.0 grams of water, so we can calculate the moles of that. So 90.0 grams of water we're going to use the molar mass to convert grams to moles. So we know the molar mass of water is 18.016 grams of water per 1 mole of water. So I put grams on the bottom to cancel out grams on top. So grams of water cancels out. I have moles. And when we calculate that, we get 4.99555. 4.99, we'll say 55 moles of water. So now we have moles of water here, moles of water here. We can plug that in here, and then we can solve for the moles of the ion. So let's go ahead and do that. So we'll have 0.914 is equal to, now this is going to be 4.9955. So it's going to be 4.9955 moles of water over 4.9955 moles of water plus the number of moles of the ions in the water or in the solution. So now all we need to do is solve this for the moles of the ions. So we're going to need to multiply both sides by 4.9955 plus N of the ions. Again, this is moles, H2O, right? Or just moles. We'll just say moles. And then we're going to have to multiply this side by the same thing. So this is going to be multiplied by 4.9955 plus N of the ions, moles of the ions. So then this cancels out with this. And so now I have, excuse me, 4.9955 moles plus the number of moles of the ions multiplied by 0.914 is equal to 4.9955 moles. Okay. So now I need to distribute. I'm going to have to multiply this to both of these. So this times 0.914, that's going to give me 4.5659, 4.5659. And then this is multiplied by this, so it's going to be plus. And again, this is moles plus, and then it's going to be 0.914 times N, the number of moles of the ions, equal to 4.9955 moles. So now I want to get N by itself, so I'm going to move this over here. So I'm going to minus 4.5659 moles, subtract that from here, and also subtract it on this side as well, 4.5659 moles. So when I subtract those, I'm going to get 0.4295. So 0.914 times N for the ions, the number of moles of ions, is going to be equal to, what did I say? 0.4295. 0.4295. And again, moles. So now all I need to do is divide both sides by 0.914. 0.914. So that cancels out. And I end up with the number of moles, and is going to be equal to, so number of moles of ions is equal to, what do I get? 0.4700. So 0.4700 moles is what I got. And these are the moles of the ions. Now, again, what I want to emphasize here is that we are talking about moles of the ions. So we don't know exactly what the formula is, right? So if we're going back, let me erase this, right? We're told we're given a metal chloride. That's all the information we're given, right? So we don't know what the charge on the metal is. So if the charge on the metal is a +1, right, like lithium and sodium, then there's only going to be one chlorine or chloride ion, right? So then the formula might be MCl, okay? If this dissolves in water, you're going to get 2 ions or 2 moles of ions for every 1 mole of the metal chloride. This is referring to the Van Hoff factor. So you got to keep in mind the Van Hoff factor, where the moles of the chloride, the metal chloride, gives you a certain number of moles of the ions when it's dissolved in water. So this gives you a 1-to-2 ratio, so the Van Hoff factor is 2, right? If the metal has a 2+ charge on it, like magnesium and calcium, then that's going to require 2 of those, right? You're going to need 2 chloride ions. So then the formula is going to be MCl2. We don't know which one it is, so we got to test both of these out. So if this is the case, right, then when you dissolve this in water, you're going to get M plus and 1 Cl minus. So if this is the moles of all of the ions, then if this breaks up into these 2 ions, then half the moles of the ions is going to be the metal, right? So let me remind you that we're trying to find the molar mass of the metal, right? So we need to find moles of the metal. They gave us grams. So remember, molar mass is equal to the grams per mole. So we need to find the moles. We don't need to find grams because they told us that the metal chloride is 10 grams, right? So the 10 grams is part of the metal chloride. So what does that mean? Okay, so we got this molar mass. So the molar mass, we got the grams of the actual compound, the full formula compound. So where am I going with this? So let's just assume, for the sake of argument, that it's this formula. What we have here is the number of moles of all of the ions. So the moles of the ions is double the moles of the original formula. So if we double the number of ions, and that's what we have here, then we can't use this number of moles for the molar mass of the substance. We have to use it. This would be the molar mass. This would be the number of moles of the ions. So we're trying to find the molar mass of the original metal chloride. So we have to, because that's what they gave us here. They gave us 10 grams of the metal chloride. So we have to go to the molar mass and find the molar mass of the chloride and then compare that with what we're given here in the number choice, the answer choices that we have. So if this is the case, then I know that the moles of the ions I have are double the moles of the original substance, the metal chloride. So I'm going to have to cut this in half. So then 47.47 divided by 2, that's going to be, here, let me write that here. So 0.47 divided by 2 is going to give me 0.237 moles, and then this would be the MCl. Again, I'm assuming that I only have one chloride, so therefore it's going to be one of these two, since these have positive charges of 1, right? So then that means that I can find the molar mass. So I'm going to get rid of this to give myself some room. So then I'm going to take the 10 grams of the metal chloride, assuming it's MCl, divided by this number of moles, 0.237 moles of MCl. And when I calculate that, I get 42.56 grams per mole. Now, if we look up, if the metal chloride is lithium chloride, or if it's sodium chloride, then we're going to calculate the molar masses of those and see which of those corresponds to that one, if any. They might not be, neither one of them might not be close to this. So then if we calculate that, we'll get these here. So let's calculate those molar masses. So the molar mass of lithium chloride is, what do I have? 4239. And the molar mass of sodium chloride is 5844. So far, if we, assuming that this is the formula and we calculated the molar mass being 42.56 grams per mole, this looks the closest so far. So if we had to choose between these two, then this would definitely be our choice. But let's go ahead and test the C and D. So in this case, if the formula is this one, then we know that this is going to break up into M2 plus 2Cl minus ions. So here we're going to have a factor of 3. So this was the moles that we calculated of the ions. If, in this case, the moles of ions are triple the amount of the moles of the original metal chloride. So this dissolving in water, 1 mole of this dissolving in water is going to give 3 moles of ions. So the moles of the original substance would be 1/3 of the 0.47. So we need to take 1/3 of this and then use that to calculate the molar mass like we did here. So 1/3 of 0.47 is 0.1566. So the 0.470 divided by 3, that's going to be 0.1566 moles. of the original metal chloride, assuming that this is the formula, right? Assuming that we're going to have a metal that has a positive charge of 2. So now, if this is the number of moles that we have of our metal chloride, then we're going to, same thing here, we're going to take 10 grams because the 10 grams is the mass of our metal chloride. So we're going to take 10 grams, divide that by 0.1566 moles. And so we're talking about MCl2, and this is MCl2. Okay? And so when we divide that, we get 6386, 63.86 grams per mole. Okay, so this is the calculated molar mass if this is our formula. So now we want to compare this molar mass with these two and see if we get anything close. So then we're going to have to find the molar mass of MgCl2 and the molar mass of CaCl2. So what's the molar mass of MgCl2? The molar mass is going to be, let's see, 95.21. And for calcium chloride, that's going to be 110.98. 110.98. So both of these are much, much bigger than this. So neither of these are going to be the formula because the molar masses of these don't even come close to the molar mass of what we calculated that it should be if this is the formula. So given all of this, it is quite clear that this is the formula of our metal chloride. This is the calculated molar mass of the metal chloride based on our data, and that matches very close to lithium chloride. So the metal is lithium. So A, in this case, A or lithium would be the metal. And that's it for this problem. I hope this is helpful. If you enjoyed this video, and again, I want to thank Emmanuel for asking the question. So hopefully this helps everyone else who has the same question. If this helped you, if you enjoyed this video, then please by all means like the video, share the video, hit the like button somewhere over here. Make sure you subscribe to my channel. Help me out here. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or problem you would like me to help you with, if you have a topic you'd like me to cover, put that down below. I'd like to help you out with that. Thanks for joining me and have a great day.